Here's another example. Find the exact value of sine of u plus v, given that sine of u is 4/5, where the angle is between 0 and pi over 2, so that would be quadrant 1, and cosine of v is negative 12 over 13, where angle v is between pi over 2 and pi, that would be quadrant 2. Okay, so we have to find the exact value of sine of u plus v. So what is sine of the quantity u plus v? So remembering the formula, right, the sum formula, it's sine, cosine, cosine, sine, where they have the same sign in the middle. So I have to figure out what this is going to be equivalent to. But note that here, I already know that sine of u, right, sine of u, I can substitute that with 4/5. I am also able to substitute cosine of v with negative 12/13. We're not given cosine of u or sine of v, but we are given some information. So you're going to have to make a right triangle in the correct quadrant, label the triangle, and then figure out what cosine of u is, sine of v is, then multiply straight across and simplify. Okay, let's take a look at angle u, right? Angle u is between 0 and pi over 2. So I am in quadrant 1. So angle u, right, is going to be in quadrant 1. Because it's between 0 and pi over 2. And we know that the sine of angle u is 4/5, right? Sine of angle u is 4 over 5. So at u, opposite over hypotenuse is 4 over 5. So 4 over 5. Therefore, right, the adjacent is 3, so you get a 3, 4, 5 right triangle. Positive 3, since it's in quadrant 1, you're going in the positive x direction. Okay, so based off of that, could we figure out what cosine of the angle u is? What's cosine of angle u? It's going to be adjacent over hypotenuse, so it's going to be 3/5. Okay, now let's go ahead and do the same thing with angle v. Angle v, it says cosine of angle v is negative 12 over 13, where angle v is between pi over 2 and pi. So between pi over 2 and pi, that would be quadrant 2. Okay, so here is my angle v in quadrant 2. Right? And we know that the cosine of angle v, adjacent over hypotenuse, is negative 12 over 13. So we'll go ahead and label that. It's going to be negative 12 and 13. The hypotenuse is always positive, so I knew the negative sign goes with the x. And also, right, this is negative x direction, positive y. So this is a 5, 12, 13 Pythagorean triple. If you didn't know that, you would use Pythagorean theorem to figure out what that y coordinate is. This y value here is going to be positive 5. Now we can figure out what sine of this angle v is. What is sine of angle v? It's opposite over hypotenuse, so it's going to be 5/13. Okay, we have everything filled out now. Again, you're given some information where you can directly substitute into your sum or difference formula. And then given the angle information, right, you place a right triangle in the correct quadrant and label the right triangle, label the sides of the triangle using the correct signs, positive or negative, and then substitute, right, the missing portions. So in this case, if I multiply straight across, since that's what you do when you multiply fractions, 4 times negative 12 is negative 48, 5 times 13 is 65, plus 3 times 5 is 15, 5 times 13 is 65. And here, these are liked terms, so I do need to combine them, right? I have a common denominator of 65. And then we have to figure out what negative 48 plus 15 is. And that is going to be negative 33. So your final answer is negative 33 over 65. Something to watch out for here, you're always going to get the same denominator right here. Okay, so you're always going to get the same denominator. If you don't, then that's a clue that you did something wrong. Okay, so make sure that you have the same denominator, right? 65, 65. You know, if you're like a 40 here, you should have a 40 here, ending up with a single fraction as your final answer. Okay, you go ahead and try this problem. It says to find the exact value of cosine of u minus v, given that cosine of u is negative 3 over 5, where that angle u is between pi and 3 pi over 2. Which quadrant is that, by the way, if you're between pi and 3 pi over 2? Right, it's going to be quadrant 3. And sine of angle V is 5 over 13, where that angle V is between 0 and pi over 2. And which quadrant is that? Quadrant 1. Go ahead and try this problem. Okay, your final answer is negative 56 over 65. So let's take a look. Cosine of u, right? U is between pi and 3 pi over 2. That pi is here and 3 pi over 2 is here. So you make your right triangle with angle u there as your reference angle. Adjacent over hypotenuse, right? Because cosine is ka, right? Or kickster x over r. You have negative 3 over 5. This is a 3, 4, 5 Pythagorean triple. So in the y direction, you're going to get negative 4 since, right, in quadrant 3, the y value is negative. So you end up with sine of u, right, sine of u being opposite over hypotenuse, giving you negative 4/5. For angle v between 0 and pi over 2, that being quadrant 1, opposite over hypotenuse is 5/13. So again, this is a 5, 12, 13 triangle. If you didn't know that, use Pythagorean theorem. You will end up with cosine of v, right? Cosine of v, which is adjacent over hypotenuse, 12 over 13, multiply straight across, combine the two fractions together, and negative 56 over 65 is your final answer. Okay, go ahead and try this problem. Simplify tangent of theta minus pi over 4. How would you do this problem if you had to simplify tangent of theta minus pi over 4? So the first step is recognizing that you have a difference going on. It's a tangent of a difference of two angles. So you can use that difference formula. So remember, the numerator is going to mirror the sign here. So it's going to be tangent theta minus tangent pi over 4. In the denominator, it's going to be opposite sign, and you're going to have two parts. The first part is always 1. The second part is the product of these. So tangent theta, tangent pi over 4. And tangent of pi over 4, you can substitute that with an exact value. What is tangent of pi over 4? Right, tangent of pi over 4, right, the y over x, or the o over a, right, you're going to end up with positive 1. So right here, I ended up with 1 everywhere I saw tangent of pi over 4. So if I go ahead and rewrite that, I get tangent theta minus 1 over 1 plus tangent of theta. And there's nothing else you can do. I mean, you can try multiplying by conjugates and whatnot, but it's not going to simplify any further. So this is it. This is your final answer. So sometimes you'll get a rational expression like this. Other times you might get like a single answer like tangent theta or like 1, that type of a thing. But the key thing here is to recognize that you have a difference or a sum formula that you need to use. Substitute any known values with their equivalent exact values, and then simplify. All right, last problem. Find all solution of sine of x plus pi over 4 plus sine of x minus pi over 4 equals negative 1 in the interval 0 to 2 pi. So you're looking for all the solutions that would make this equation true, all values of x, such that the angles are between 0 and 2 pi. So how would you solve this? So remember, on the quiz and test, you're going to have a lot of problems where you're going to have to find the solutions, right? So this is a possible question that you might see, and it's going to be embedded with all the other identity stuff. So here you want to be able to recognize that you have a sum, right? Sine of a sum of two angles, and the sine of a difference of two angles. You want to be able to use that sum and difference formula. Okay, so what I did was I use the sum formula here, so we get sine, cosine, cosine, sine, with our u being x, with our v, the second angle, being pi over 4, plus, and then I have a sine, difference of a sine right here, so I have sine, cosine, cosine, sine, where you're going to have minus with the u and v according in the end. It's equal to negative 1. Then you ask yourself, like, is there something I can substitute? Like, if I see cosine of pi over 4 and sine of pi over 4, I can replace those with their actual ratios, right? Root 2 over 2 and root 2 over 2. I went ahead and substituted it in, and then recognize that I have sine of x times root 2 over 2 twice, right? So this part right here is going to be 2 sine of x root 2 over 2. And then recognize that I have positive cosine of x root 2 over 2 and minus cosine of x root 2 over 2. So these parts, right, these two terms would cancel out. So on the left-hand side, I end up with 2 sine of x root 2 over 2 because I have two of them, so I combine them. And on the right hand side, I end up with equaling -1. So let's go ahead and solve this problem now. Right, we did all of that work, and now we end up with this equation here. So I can divide by 2 on both sides. So I can divide by 2. And then since these are being multiplied, I can multiply both sides by the reciprocal. So I can multiply both sides by 2 over root 2. 2 over root 2, so these cancel out. And you get sine of x is equal to -1 over root 2. You can leave it as -1 over root 2, or you can rewrite that as -root 2 over 2 when you rationalize. So remember, your original question asked you to find all the values of x where it's between 0 and 2 pi. So you're looking in the unit circle from 0 to 360 or 0 to 2 pi, all 4 quadrants. Ask yourself, where does your y value, because it's a sine, where does your y value equal -root 2 over 2 from 0 to 2 pi? That happens in the bottom 2 quadrants, right? Bottom 2 quadrants at 5 pi over 4 and 7 pi over 4. So that is your final answer. The two solutions to this equation here, right? The two values of x that would make this statement true are 5 pi over 4 and 7 pi over 4.